So let's move on to our last question. In question, we are going to determine the internal forcing members DE, DL, and LM and EL. As you can see, we cannot cut through the member EL, but we can cut three other members, the DL and LM. So after calculating the magnitude of these forces, we can determine EL as well by method of joint. So it's not possible to determine this member by method of sections. As always, let's start off with calculating the support reactions here. X is equal to 0 since we don't have any horizontal external force, and by symmetry we know that AY and IY are same and equal to 3L. As you can see in this structure, two of our unknowns are passing L and two others are passing D. So if we write moment equations about these 2 points, we can calculate two of our unknowns, and then later by writing equation of equilibrium along y direction or similarly x direction, we can determine our third member. So let's write moment equation about L, point L. By writing moment equation around joint L, we can determine the internal force of DE, because two of other unknown or other internal forces are passing by joint L and they don't cause any moment about this point. And so let's start. What we have is 3L, which is the magnitude of our support reaction. We already calculated it. It's the negative because it's causing a moment about point L, which is clockwise, and we assume that positive direction is counterclockwise, so we indicate it with minus. Similarly, we have this external force, this one and this one. All of them are causing counterclockwise moment about point L. So all of them are shown by a positive sign, and the distance are 24, 16, and 8. So it was the moment caused by external forces and our support reaction. So let's move on to our internal force, which we can determine the amount of dE. And in order to, like the previous question, in order to simplify our calculation, we can decompose the force in member DE into its y component and x component. I decompose it at point E here because if we decompose this force DE at point E, the vertical component of DE is passing point L and doesn't cause moment about point L, and only a horizontal component of DE is causing moment about point L. So we can simplify our equation even further. The horizontal component of DE is equal to D times cos 30, which is this angle. And we need, in order to calculate the amount of moment caused by DE, we need to know this distance. In order to find this distance, it's important to know that it's not equal to 6 feet because these two lines are not parallel. One of them is 25 degree and one of them is 30 degree. If we imagine two triangles where one of them is 25 and one of them is 30. Okay, we know that perpendicular side of this triangle is equal to this distance, which is 24, 24 times tangent 30, and again 24 tangent 25, tangent of 25 degree. So if we subtract this perpendicular side from this one, we can find the increase in our vertical member. And if we add it to our this first figure, we can calculate or determine this distance, as you can see here. So this term is equal to our distance. If we solve this equation, we can determine the amount of DE and its compression member, since the direction of force is toward joint D, so it's compression. And let's move on to writing moment equation about point D in order to calculate internal force in member LM, this member. Similar to previous equation, we have support reaction to L, and again it's negative since causing uh, clockwise moment about point D. And this time we have two forces because this point is D, and this external force doesn't cause moment about point D, so we have just two external force, this force and this force, which they are causing moment about point D, and the distances between them also is 16 and 8. And finally, our internal force of Lm, which is causing moment about point D, and two other members doesn't cause any moment about point D because they are intersecting at point D or passing point D. Similar to previous question, I decomposed Lm at point M because if I decompose it here, the vertical component of Lm is passing point D, so it doesn't cause moment about point D, and just the horizontal component of Lm is causing moment. This is the horizontal component, Lm times cos 25 degree. And similarly, we need to determine this distance that's similar to our previous equation. We can determine the amount of this distance with this term, 16 tangent of 30 minus 16 tangent of 20 plus 6. By solving this equation, we can determine the magnitude of Lm, which turns out to be 4.57 L, and it's a tension member since the direction of force is outward the joint M, so it's tension. By knowing our two unknowns, which were dE and Lm, we can determine the amount of our third unknown, which is dl, by writing equilibrium equation along x direction or similarly y direction. And as you can see, all of our three internal forces have horizontal equation. We know already the amount of the dE, and the horizontal component is dE cos 30, and it's negative because the direction is toward left, and we assume that toward right is our positive direction. And Lm cos 25, which already we calculated it, is horizontal component of it. And finally, our unknown is dl cos theta. In order to determine the horizontal component of dl, we need to determine first of all the magnitude of theta, the angle of theta. Again, in order to know the amount of theta, we should know this length x. then we can determine theta by we know that theta is equal to inverse tangent of x over 8. 8 is the base of the base of our triangle. Let me draw this triangle so you can understand better trigonometry terms here. This angle is theta, and the perpendicular side we indicated it with x, and this base side is 8 feet. In order to calculate the amount of x or the length of x, I subtract this length, which is 24 tangent of 25 degree, from these terms, that is 16 tangent of 30 plus 6, which gave us the length of x, 4.05 feet. And we know that theta is equal to inverse tangent of x, which we calculated, over 8. So we have theta equals 26.85 degree. By knowing the amount of theta, we can solve this equation, and it gives us dl equals to 0. So dl is 0 force member under this arrangement of forces. Okay, in order to calculate the amount of el, we need to use method of joints. And what we have for joint E is one external force, which is downward, and there are three members connecting joint E, DE, FE, and EL. By writing equilibrium equation along x direction, we can see that DE and FE are equal. Already we know the amount of DE, so right now F is not unknown anymore, and we know it. Also, we could understand by symmetry that these two forces are equal. So the EL are unknown. EL is on left, and we can calculate it by writing equilibrium equation along y direction. So what we have here is external force of L, which is downward, so it's negative, and EL, which we assume that is upward, so it's positive, and DE is sine of 30, and two of them, because we know that FE and DE are equal. By solving these equations, we have EL equals to minus 3.78 L. This negative sign indicates that our first assumption was wrong, and we should correct our direction, and it shows us that the EL is downward and is tension member, and it's not compressive. That's it. We determine all of our unknowns. That's it. Thank you very much for watching this video, and please, if you find this video informative, like us and subscribe this channel.